Hi, I'm Chris Hamlett, and I'm the National Outreach Officer for Discover Materials.
I'm Dr. Becky Waldram, and I work for Swansea University.
And we're going to be talking over the next 10 minutes or so about material science and time. This was inspired by the recent British Science Week, whose topic was time. So we thought, yeah, there's definite links between material science and time. So let's explore more. So, what are materials? Basic materials are the stuff that make up things that are around us every day, such as cameras, glasses, the clothes you wear, paper you write on, even the plants in your room. And these materials can be like metals such as iron, aluminium, wood, plastics like polypropylene and acrylic. Why don't you could pause this video for a couple of minutes and see if you can match some of the materials on the right to the objects on the left of the screen. Around the home, there's plenty of materials, such as your boiler. You've got copper pipes coming out of it to carry hot water around the house to heat the rooms. And also within the boiler, you've got the plastic pipes as well. Your bike frames, probably aluminium, maybe even carbon fiber, which are lightweight materials. And the tables may well be made out of wood, get metal tables. So materials are pretty much everywhere. But how have they evolved over time? Becky?
So materials have been around for a very long time, but not necessarily in the way that we see them today. Some of the first materials that we used have actually been used to describe the ages that we've lived through and used to describe eras of time. So we've got the Stone Age, where humans started using stone to build buildings. So we've got an example of like Stonehenge on the slide there. Humans started to build tools from stone, started to use flint to make fire. And it helped us progress, build new things, and helped human civilization to progress. And as we started to look further into those rocks, we found that there were actually other materials inside that we could use. So, for example, we then had the Bronze Age as the next era, where we managed to extract that material from the ground and actually melt it into molds to form things that we could use, like little arrowheads, to make tools that were much better, to start eating a wider variety of food. And then this progressed again when we managed to extract iron from stones, and we could use this to make really, really strong tools to help develop our civilizations, to build new buildings. And as iron development progressed over actually a very long period of time, we could then start to use it to make things in the Industrial Revolutions, things like machinery, things like trains, and that has come up all the way to the modern age. Much more recently, we've moved into something that we call the Silicon Age, and this is a lot more around the advent of computers. And silicon's an interesting run because before that, bronze and iron, which were metals, shaped our society, but we've moved into an age of silicon, which is actually falls between a metal and a non-metal on the periodic table, and we use that now to power a lot of devices. And I think, Chris, you've got some information about how silicon has shaped your life.
So I have this is actually a picture of my first computer that I had. It was a ZX Spectrum Plus 3. It had an integrated disk drive, and also it had an amazing 8 colours on there. This was an example of one of the games that was on there, and it was fantastic at the time, sort of growing up in the 80s with this kind of technology. But then it wasn't just computers. So mobile phones as well have changed. So this is a picture of my first phone. It was great. It had 2 colours on there. You could phone, you could text, you could even play games like Snake. But nowadays, with advancements in computer manufacturing and chip design, we can now merge computers and phones onto a device I'm sure the viewers are a lot more familiar with, the smartphone, where you can we can phone, play games, take videos, photographs, basically live your life through the phone. And they're incredible devices. And the advancement in materials and manufacturing means that there's more than 30 elements from the periodic table in a smartphone these days, which gives it fantastic functionality, like, as I said, camera, speakers, but it does make it quite tricky to recycle. If you'd like to find out more, we've got a couple of videos on our website. The first one, the materials in a mobile phone, that looks at the different devices in the phone, and it was recorded during lockdown by the great science communicator Marty Jobson. And then also we have had a look at where materials in a mobile phone actually comes from in the second QR code there, where we had 3 sixth form students looking at where the raw materials in a mobile phone comes from. So please have a look via those QR codes if you're interested. But materials are more than just the devices in your pocket.
So obviously, we've looked at how different materials are developed over time and how they've been used, but we also need to think about how we design products and things like aircraft out of those materials. So this is an example of the de Havilland Comet, which was developed mostly during the 1950s. I don't know if you've noticed when you've ever been on an aeroplane that the windows are always round and have curved edges. And that's because the original design of these aircraft actually had square windows, and they found that actually that design caused really, really big problems. And actually there were 2 or 3 aircraft that split apart, and that was due to the stress that was caused by those materials being square rather than round. So if you think about a square, it's got some really sharp points on it, and it's those sharp points which made the windows, we call it fatigue. They basically get really stressed and tired, and the material breaks at that point. So that's why from then on that design has evolved over time, that aeroplanes now all have round windows, so that stress falls evenly over that entire structure of the window. So that's an example of how design has evolved, how human design has evolved over time. But Chris, how has nature evolved over time?
Well, nature has got a huge array of materials. I mean, it's been around since the dawn of time and can provides loads of inspiration for materials. And one of them are these so-called smart materials, or materials that do something pretty cool. And one example is a pine cone. So you may notice pine cones outside, they might well be open and during dry weather. But when they get wet, something cool happens. So this video is a time-lapse video, or a video showing stuff happening over time. So, and if we put this, so here's a pine cone. I'm going to show a time-lapse video now of putting it in water. And what you notice is that it closes up. And this is due to some naturally occurring smart materials in the pine cone that absorb the water and actually close up the scales of the pine cone. So this is to protect the seeds when it gets really, really wet and damp. And then when the weather gets drier, the pine cone can open out and can help spread its seed. So this is just one of many examples of smart materials in nature. But timescales are also important in liquids and fluids. So here are some high-speed videos of what are known as Newtonian and non-Newtonian fluids. So on the right, you can see that a ball bearing is dropped in water and it behaves as you would expect. Splashes around the ball bearing, just drops in. But in the oobleck on the right-hand side, you can see that the water, the ball bearing just bounces straight off. And this is an example of a non-Newtonian fluid. So you can have a go at making some oobleck at home using corn flour and water. And this kind of behaviour is inspired the development of protective materials. So this science putty that you may have seen, this is an example of a shear thickening or shear hardening material. So you can pull this stuff really slowly and it stretches out sort of like plasticine or blue tack and is very ductile. But if you pull it really, really quickly, it just snaps, a bit like sort of like glass or something. It becomes brittle. So it sort of like hardens up. And as a result, this can be used to protect you against impact. And it's almost a solid version of the oobleck from the previous slide. If you'd like to learn more about it, you can follow this QR code where John Wood explains how crash helmets can be made out of this kind of material. So there's some examples of some materials over time. Now it's your go. You can have a go at some stuff at home. What we'd like you to do is to think of a material or something that happens to a material over a long period of time. Get some photos of it to see how quickly it happens, and then email them to us at info@discovermaterials.uk, and then we can put them up on our website. But here's some ideas.
So the first one that takes a long time to happen is something called corrosion. And you might have seen this kind of red rust type material like in this image here. And this is a process that happens over a really, really long period of time to metals, especially something like steel. And we call that corrosion or rusting. And this is something that you can have a go at home. And it's something that will take between several hours and several days to happen. So the idea here is you take a small piece of metal, steel or something that's steel based will work really well from this because the rust is a nice reddy orange color. And then to make something like this corrode, you need to put it into what we call a corrosive liquid, or you can have a look at some of these different material, these liquids, to see what the difference is between them. So some examples of where you could put your metal are in water, salt water, vinegar, lemonade, or even baking soda in water, and see how that affects the corrosion of this piece of metal. So you can see here that we've got a small piece of metal in that liquid solution. And here's an example of what you might see over a few days. If you take some photos at several different hours, you might start to see that your water changes color, and even I think your metal might start to change color as well. And you can see here we've got an example of before and after corrosion. And this is a process that has taken several days to happen, but you can stitch together some images to speed up that process, so you can see the different stages of that happening over time. So that's one example of an experiment you could have a go at home.
The other one is growing crystals. So these are some examples of some crystals that I saw at Edinburgh Museum of naturally occurring minerals, and they look absolutely gorgeous. But you can have a go at growing some yourself at home. So for this, the sugar or salt works quite well. Dissolve as much as you can in some hot water, but just be careful not to burn yourself with the hot water. Then you pour a little bit into a dish and then leave it to evaporate, which could take a couple of days if you've got a lot of sugar or salt in there. And here's an example of one that I did actually during lockdown, where I took some sugar or salt at the top there, dissolved it in some hot water, took a few drops, put them in these little petri dishes, and then after a few days, you can see the bottom images here of the sugar and the salt that have recrystallized and changed shape over a few days. We've actually got some more information on our website via the link below as part of a project we ran with the Royal Society of Chemistry known as the Cocoa Micro Booklet. So if you follow the link there, you can find out a little bit more about crystallization. So we very much look forward to seeing some of your photos of either corrosion or rusting or recrystallization. Also, if you'd like to know more about material science, you can visit our website or one of our social media channels. But yeah, thank you very much, Becky, for coming along for this. It has been really interesting. And we hope you guys have enjoy this and have fun at home. Thanks very much.